All right, so today I'm going to teach you a process called synthetic division. And synthetic division, like the word synthetic means like fake, right? And so this is like a fake way to divide polynomials. We are trying to divide this cubic polynomial here by this binomial right here. You see it's a linear term because it has x to the 1. And so we're just going to do that because we're going to need it for next class to finish a process that we're going to have to do. So what you do is this. You could see this written long ways like this, or you might see it written like this: x to the third minus 7x squared plus 14x minus 18 divided by x minus 5. So you can see it either way, it doesn't matter. So what you do is you take the opposite, or basically you take the 0 of this factor right here. So x minus 5, so what we're going to do is put a positive 5 in a little box over here to the side. So you basically take the opposite, right? Because 5 minus 5 is 0, so we're testing out the number 5. So if it's like a plus 2 over here, we're going to put a negative 2 inside the little box. All right. So now you're going to take all the coefficients of this piece here, of the numerator. So 1, negative 7, 14, and negative 18. So 1, negative 7, 14, and negative 18. So when you do that, this problem is pretty normal, but you need to make sure, because later on we're going to have some special ones, you need to make sure that nothing's missing. If the highest power is x to the third, then you need to also then have x squared, x, and then your constant term. So if something's missing, like if this x squared term were missing, you'd have to put a 0 in its place to hold its spot. All right, so leave a little space and we're going to draw a line. Okay, so here's our process. We're going to take this first number here, bring it straight down. Then we multiply this number by what's in the box. So 1 times 5 is 5. And then you add. You always add. So the first number comes straight down, you multiply, put it here in the next spot, and then you add. Negative 7 plus 5 is negative 2. And every once in a while the numbers get large and you need your calculator, but most of this should be pretty quick and easy. All right, negative 2, then you just do it over again. Negative 2 times 5 is negative 10. And then I add again, so I get positive 4. 14 plus negative 10. Then multiply again. 4 times 5 is 20. And then you add, so I get positive 2. Now this part right here, this is going to be my remainder. You know, when you divide, if something doesn't go perfectly, there's a remainder. So this is how we're going to write our answer. So our answer has a remainder, and when we look at this thing, we have to notice that what's happened to us, we have something with x to the third, and we have divided an x away. So everything is like reduced in power, our answer. So since this thing started with x to the third, that means that my answer now starts with x squared, because everything's knocked down a power. And this x squared then goes down to x, and then there's my constant term. So here's how we need to write our answer. The answer to this problem up here is 1x squared minus 2x plus 4. My remainder is positive, so I'm going to say plus 2 over, what was I dividing by? X minus 5. And so that's it. And there is your answer. Okay, now this is only can be done when you have like a nice easy thing you're dividing by. Later, if you take pre-calculus, you'll learn long division, and which is like long division you learned in elementary school. But synthetic division is a nice quick and easy thing you can do to basically test out to see if this number goes in perfectly. And this one didn't. But all right, so here we go with this next one. So I put a negative 2, the opposite of the plus 2. And so I take 5. 5x to the third, 15x squared, 6x minus 8, nothing's missing, so 15, 6, and negative 8. Make sure you put the signs correctly. Leave a little space, draw a line. First number comes down, 5. 5 times negative 2 is negative 10. Add these together, 5. 5 times negative 2 is negative 10. Add these together, get negative 4. Negative 4 times negative 2 is positive 8. Uh-oh, look at that. Remainder is 0. That's great. That's what we're going to be looking for when we do these problems, when we use this for the purpose that we're going to use it for in our problems. So we're not going to just do synthetic division just to divide, just to do it. We're going to use it for something. But anyway, So this highest power was x to the third, so I'm going to have x squared. Then x right here, and I have no remainder, so that's great. So I got 5x squared plus 5x minus 4. So if I started off with x to the third, my answer is going to have x squared. Same as over here. All right, so let's go to this guy here. So now you notice I have an x squared, so my answer is going to be a little different than before. So this is x minus 10, so I'm going to put positive 10, 7, negative 62, and negative 77. So these numbers are getting a little large, but let's see if we can handle. Bring 7 down. 7 times 10 is 70. That's not too bad. Add that up, I would get positive 8. 8 times 10 is 80. So that's not too bad, 3. So I do have a remainder. All right, so let's see. It was x squared, so that means that my next part is going to be just x, and then this has nothing at all. So my answer to this question is 7x plus 8. My remainder is positive again, so plus 3 over what I was dividing by, x minus 10. All right, so this is had a remainder, but I want to go back and show you up in number 2. What happened here is this problem was really 5x to the third plus 15x squared plus 6x minus 8. It was divided by x plus 2. I want you to remember like a little fact. If you like number facts, like back in elementary school, if you have something like, let's say, I don't know, 12 divided by 3 is 4. Do you remember that once you knew that, you could also do this? You could then say that 12 equals 3 times 4, right? So I can say that over here. I can now say that 5x to the third plus 15x squared plus 6x plus 8 is equal to x plus 2, that thing, times 5x squared plus 5x minus 4. All right, so do you see what the synthetic division did for us? And this is what we're going to use it for. It factored my problem for me. I didn't know that there was an x plus 2 that could come out of here. There was no way that I could factor that probably, but what it did is it broke it into 2 factors. And then once I get a factor small like this, maybe I could factor it more myself. So that's going to be our goal. All right, so let's look at number 4. So let's see. Put a negative 4 in the box. And look at my problem, x to the fourth. Uh-oh, where's the x to the third? It's missing. Then I get x squared, x, and nothing. So it's a 1x to the fourth. X to the third is missing, so we're going to put that 0 I was talking about. Then I'm going to have negative 19, then negative 20, and negative 32. So lots of negatives, be careful. Draw a line, bring this one down. So 1 times negative 4 is negative 4. Add that up, you get negative 4. Multiply negative 4 times negative 4, 16. Add that up. Let's see, that gets me negative 3. Multiply, 12. Add that up, get negative 8. Negative 8 times negative 4 is positive 32. So looking good, remainder 0. That makes us happy. So this was x to the fourth, therefore this would be x to the third. This would be x squared, and x and nothing. All right, so my answer is x to the third minus 4x squared minus 3x minus 8. Okay, all right. And it went through perfectly, no remainder. So if I wanted to, I could probably, I could write this kind of thing again for it, but I was just showing you that just for later, just so you get used to it. All right, so let's set this one up, and then let's see if you can do it yourself. So think for yourself for a second, what number is going to go in the box? All right, hopefully you thought negative 1. Look across here, 3n to the fourth, n to the third, n squared, and then it jumps right to here. So there's an n missing right here. There's the linear term missing. So I'm going to put a 0. 3, 10, 16, 0, and then negative 5. Leave a little space, draw a line, bring a 3 down. Now pause the video for a second and see if you can complete this problem right here. All right, 3 times negative 1 is negative 3. Add up to 7. 7 times 0 is negative 7. That adds up to 9. Then I get negative 9. Add that up, negative 9. Multiply to 9. Adds up to 4. Remainder. Okay, this was n to the third, because 1 less than n to the fourth, n squared, and n. All right, so here's my answer. 3n to the third plus 7n squared plus 9n minus 9. And then remainder is positive again. If it was negative, I would put a minus, but it's positive. So, plus 4 over n plus 1. Okay. All right, so I just want to do one last little problem here. I'm going to show you what we're going to use this for. And this problem you don't have to copy down. I just wanted you to kind of watch and see. So this problem, it was like a multiple choice. So it was just a way I could get the graphs. So the answer to this question is letter D. Letter B is the graph of this problem. So what we're going to do is we're going to be looking for x-intercepts. You see how this thing goes through 2 right here? And it also goes through 5, but we'll just do the 2 for now. So watch what happens when I get that 2 right there and I do my synthetic division with a 2 on this problem here that I'm given. So 1, negative 12, 45, negative 50. All right, nothing was missing, so bring down the 1. 1 times 2 is 2. Add this up to negative 10, multiply to negative 20. That adds up to 25. 25 times 2 is 50, and I get a remainder 0. And so when you put an x-intercept in the box, the remainder will always be 0. So what you've effectively done, this was x to the third, so this is x squared, x. You have now done this. You know that x to the third minus 12x squared plus 45x minus 50. You now know that 2 is one of the zeros. So that means that x minus 2 is one of the factors, and then there's the other factor right there, x squared minus 10x plus 25. And so that's like what we were doing, or what I was showing you on example number 2 right here, how when you divide something it comes out perfectly. You can bring what you were dividing by over to multiply, and it's supposed to multiply back to the original. So we have just proven, because that's a 0, that x minus 2 is a multiplier to x squared minus 10x plus 25 right here to get me my original. And then look what I can do. Once I have that broken down, I can factor it again. X and x. What multiplies a 25 and makes negative 10? Well, negative 5 and negative 5 do that. So there's I have now factored this whole problem. And so once I break it up with my synthetic division, then it helps me to like take out a piece of it, and then what's left is easier for me to work with. Okay, so that's going to be our ultimate goal. But anyway, that's it. And go and do your few problems on synthetic division to show that you know how to do it. Bye-bye.